Hello everyone. Well, what do we got here? We got a square root function. It is a modified version of the original square root function, g of x equals square root of x. You can tell that by the square root symbol in the f of x function. In order to do a transformation, the way that we've been doing it in class, we need to be able to list some ordered pairs that are on the original function g of x equals square root of x. So some good ones to list are 0, 0, 1, 1, 4, 2, and 9, 3. Then, everything that we see in the f of x function that's different from the g of x function causes some sort of transformation. Like this minus 6, this minus 3, this minus sign in front of the x, and the 4 out front. Looks like we're going to have to make 4 changes to our ordered pairs. Let's figure out what they are and what the order is that we should do them in. All right, so the minus 6 here at the end means we're going to shift the whole graph down 6 units. And the way we accomplish that is we subtract 6 from y. The minus 3 on the inside means we actually shift to the right 3 units, and we accomplish that by add 3 to x. That's the one that's backwards from what we think it should be. There's a minus sign in front of the x. That means we're going to reflect over the y-axis, and we accomplish that by changing the sign on all the x values, or multiply x by -1. That's actually the only reflection on this one because the 4 out front doesn't cause a reflection. The 4 out in front causes a vertical stretch by a factor of 4. And the way we accomplish that is we just multiply all the y values by 4. So multiply y by 4. You want to make sure you get this problem right. Make sure you do the horizontal shift first and the vertical shift last. You can do the other two things, the multiply y by 4 and the multiply x by -1 in any order you want, but I prefer to finish with my x's before I move on to my y's. But it really doesn't make a difference. That 2 and 3 could be in a different order. Okay, let's go through and change our ordered pairs. The first step is to add 3 to all the x's without changing the y's at all. 3, 0, 4, 1, 7, 2, 12, 3. Okay, I have added 3 to all the x's, sorry about that, and not changed the y's at all. Okay, now we're going to multiply the x's by -1. Okay, so -3, don't change the y, -4, don't change the y, -7, don't change the y, -12, don't change the y. All right, next step. We're going to multiply the y's by 4, and we're not going to change the x's at all. So -3, 0, didn't do anything there. But right here, we multiply this 1 by 4, we get a 4. We multiply this 2 by 4, we get an 8. And we multiply this 3 by 4, and we'll get a 12. Last step, we're going to subtract 6 from all the y's and leave the x's alone. So -3, -6, -4, -2, -7, +2, -12, 6. Okay, we've got our ordered pairs. Now, one thing we need to note about the square root graph is a little bit different than the other functions in that it doesn't go forever in both directions. It actually has a stopping point. And it has another direction where it goes on forever and ever and ever. 0, 0 is where this graph stops on the normal g of x equals square root of x graph. So now our new graph is going to have a stopping point at -3, -6. And when we get to the other end, it's going to keep going forever and ever and ever. So let's plot our points. We've got an ordered pair at -3, -6. So -3, -6, right down there. Okay, -4, -2, -4, -2, -7, 2, 2, 3, 4, 5, 6, 7, 2, and -12, 6. Well, you know, this happens every now and then, so let's go like this. There's -12, 1, 2, 3, 4, 5, 6. Right around there, I would say. Okay, so this graph really got stretched out a lot. Still the square root graph, but it really got stretched. Hey, you want to get the domain and range of this? The easiest way to do that is to note this point right here. the -3, -6. That makes it fairly easy to see the domain is -infinity all the way up to the x value -3, and the range is going to be the y value of -6 all the way up to infinity. All right, we'll call that one done. I hope that helped. Thanks for watching.